All right. For the next part here, we're going to be graphing some lines and we're going to be using the intercepts. And the reason why we can use the intercepts to graph a line is 2 points is enough to determine a line. Hopefully one that's drawn a little bit more straight than that one. Let me get my straight edge out. That's a little bit better. That arrow's a little bit off there though. There we go. That's a much better looking line. So you only need 2 points. So we're going to use these intercepts to find it. The nice thing is if you remember what the points are supposed to look like, it's really easy to calculate them out. And this is the key info right here that you need for these and why this works, and it works so well. For the x-intercept, y equals 0. For the y-intercept, x equals 0. So whichever one you're looking for, make the other one 0. All right? Now, I'm going to go through and I'm going to find the x-intercept. So I'll write my equation, 2x plus 4y equals 16. And if I'm looking for the x-intercept, I want y to be 0. So what I'm going to do is rewrite the equation, but this time I'm going to plug in 0 for the y coordinate. And what that does is it cancels that whole term out. When it's in standard form, it's real nice. It just disappears. And we're left with 2x equals 16. Divide both sides by 2, you get x equals 8. So my x-intercept is 8. Now I do the same thing for the y-intercept, except this time, with the equation 2x plus 4y equals 16, I'm looking for the y-intercept, so I'm going to make the x 0. Now 2 times 0 is 0. I get to just ignore that part of the equation, and I'm left with 4y equals 16. Divide both sides by 4, and you get y equals 4. So my y-intercept is 4. Now with those two pieces of information, all I need is let me move my picture here a little bit, kind of move this up out of the way here, so then we can make ourselves a graph. Now, when you're doing this, when you're starting out, it's really good habit to label all the points, 1, 2, 3, 4, 5, on each one of the axes. And it's a good habit to label the axes as well. 1, 2, 3, 4, -5, 1, 2, 1, 2, 3, 4, 5, -5, 1, 2. So, if you are very careful about doing this, you're using graph paper, it's a lot better. Way better than if I were to draw a graph and have crooked lines in it. It's not going to come out looking very neat. Let's plot the x-intercept in red. That's on 8 on the x-axis, so I go to 8. So there's 5, 6, 7, 8. Oh, right on the end of my graph. Fits perfectly. And then let's do the y-intercept, also in red. It's 4, so I go to positive 4 on the y-axis. And there's my 2 points. I use a straight edge. To connect the dots, draw it a little bit beyond them, and there I have my equation. And if you want to be really nice and neat, 2x plus 4y equals 16. You can write the equation out by one of the ends of the line that you drew. Make sure you have arrows on them because it does go forever, but that's the neatest way to draw out a graph there. And that's all we need. I really like this because when I see an equation in standard form, I basically, I'm looking for the x-intercept, cover up the y term. I don't even see that exists. I just put my thumb over it on the piece of paper. I can't show you because If I put my thumb on the screen, you don't get to see it. But basically, I just cover it up because it's gone. And whatever little equation that's left, that's what I solve to find the x-intercept. And same thing with the y. I cover up the x term, solve what's there. So that's how you graph using intercepts. Some people don't like it. I think it's actually one of the easiest ways to graph because it's really easy to calculate out those 2 points. It gets a little bit more difficult when it doesn't come out to be nice round numbers. Like if this had equaled 15 instead of 16, I'd have halves in there, and then it's kind of nasty that way. But for the most part, this is a pretty good way of graphing lines.